Okay. Uh, we discussed, I will tell you about we will revise binary shifts and also the binary addition as well. So let's do this exercise. This is a formal assessment for that, and let's begin it. And suppose we have a number 011010000. This is an 8-bit number. What we have to do, we have to first find the binary value of the given binary number. We have revised it already. One, we put this value 2 4 8 16 32 64, and then we have 128 or minus 128. Let's keep it that way, uh, as this is 0, so it won't affect. 64 plus 32, 96 plus 8, that will give you 104. Find binary value. So this is the part A. The answer is 104. Now the second, shift three places right and comment. Let's shift this number to shift three places. Let's say if we shift it to one place, well, what will we have? The rightmost zero will become unavailable, so we are left with the two zeros. And this is 1, 0, and double 1. How many bits are there now? 3 plus 3, 6. So will put two zeros behind. That will become a right shift 1. Shift 1. This is shift 1. Now let's do shift 2. Shift 2, if we put another bit, now the second bit, we have to do the three places. Now for the shift 2, what will we have? We'll have the only this one 0 shift to the right, it will vanish, and we'll have left with 1 0 0 1 0 double 1 0 1 0 and double 1. So we will have three zeros behind. And now next we again do one more shift. Let's do the shift 3. Shift 3, we will have this 0 will be vanished, so we will have no 0, we will have 1 0 double 1. And what will we have? We'll have to put four zeros behind, so these are the four zeros. Let's forget this one. Now four zeros, double 1 0 1. Now the number has become, we have shifted four digits to the right. So we have shifted three places to the right. This number has become 13. How? Let's say, what 52, 104 divided by 2 is what? It is 52. So this number will be representing 52. How? Let's try it. 1 2 4 8 16 and 32. See, 32 plus 16, 48 plus 4, 52, as we had only once, so that is giving 52, the first shift. Now the second shift, we shifted it again. This number will be representing 26, because right side shift divides the number by 2. So let's try it. 1 2 4 8 and 16. 16 plus 8, 24, plus 2 gives us 26. What is this? Give us 52. 52, half of 104 is 52, half of 52 is 26, and again if we shift again right, it will also get halved. 1 2 4 8, rest is won't be added, so we won't need that. 8 plus 4 12 plus 1 13. That gives us the value 13. So 104 divided by 2 gives us 52. With the first shift, this number became 52. With the second shift, this number became 26. With the third shift, this number became 13. This is how, after shifting it to the three places, the number will become four zeros, double 1 0 1. That will give us the result 13 in binary. Find, find binary value of another binary number. Okay, this is another binary number. We have to find its binary value. 1 2 4 8. Add them, we get the result as 15. Shift four places. If you shift it to the four places, this one will be vanished. Shift one, we'll lose the bit, so we will have four zeros, triple one, and we will have another zero here, because one bit will be lost, so we will be left with three ones. Now shift 2, let's do see shift 2. We will have this one will be again lost. We will have left with only 3 5 only two ones. So this is what 2 3 5 3 8. And now if we do shift 3, what we will have again uh, 6 7 zeros and 1. And if we do shift 4, we will lose all the values, so we will be left with only zeros. So this is why our short with four shifts, all the ones will be lost and only the zeros will retain. Now next question, it is asking convert 29 and 51 into 8-bit binary. Okay, let's do see first convert 29 to 8-bit binary. 29, the closest number that is smaller to smaller than it. Let's say write down the table 128, 64, 32, uh, and what we have then 16, 8, 4, 2, 1. So the number we have is 29. So let's say 29, and 128 of course is too far from it. This is too far. 32 is greater than it, we won't will add 0 with it. 16 is smaller than it, we will add 1 with it. Now 16 plus 8, of course we will add 8 because 16 plus 8 gives 24, and 24 is smaller than 29, we will add it. Now 24 plus 4, 28, we will again add 1 with it. It's 0 and 1. Triple 101, that will give us the number 29. Next number is what? 51. We are solving the part A. Okay. 51 is what? We will again use these numbers. 128, of course this is greater, this is greater, and again 32, that is the closest smaller number than 51 into powers of 2. So we will put 1 with it. 32 plus 16, 48, it is also smaller than that. 48 plus 8, 56, now is greater than, we will put 0 here. 48 plus 4, 52, it is also greater than here. And again 48 plus 250, that is smaller than 50 plus 1, now 51. So this number gives us the value 51. Now next question, it is asking us to add them both. Let's do the part B. In part B, apologies for that, I will remove it with the eraser. Now if we have to add them, 1 plus 1 gives us 0, and carry will be 1. 1 plus 0 plus 1, that gives us 0, and carry is 1. 1 plus 1 is 0, 0 and carry is again 1. 1 plus 1 is 0, and carry is again 1. 1 plus 1 plus 1 gives us 1, and carry is 1. 1 plus 0 plus 1 gives us 0, and carry is 1. 1 plus 0 plus 0, 1, and the final number is 0. So this number is our final addition. 29 plus 52 gives us 80. So this number will be representing what? 80. And next is convert 75 into binary. Let's say it is asking another question to convert 75 into binary. Let's do it this way. 75 into binary: 128, 64, 32, 16, and 8, 4, 2, 1. Let's convert it into binary. The number is 75, 128 is bigger than it, 64 is smaller than it, we will add 1 with it. 32, 64 plus 32 gives us 96, which is greater. 64 plus 16 gives us what? 80. So it is again the bigger number. 64 plus 8 gives us 72, so we will put 1 with it. It's 0 and 1, 1. So 1 double 0, 1 0 double 1, this number gives us what? Number 75. So now if we add the result, shift finder. Okay, we haven't done the part C. Let's do the part C. In part C, what we have to do, we have to shift the number 3 places. Which number? We have to shift this number 80 to the 3 places right. So if we put these 3 zeros will be vanished, we will be left with only 1 0, uh, this 1 0, and 0 1 0. We will have 0 1 0, and we will have 3 zeros are removed, so 3 zeros will be added at the back. So 4 zeros, 1 0 1 0, that number becomes 10. So this is what we got with shifting it result to the right 3 places. So 80 became this one. This is the part C is done. Next what we do, we add the result, convert 29 and 51 into 8-bit binary. Next add results. Okay, let's see the solution in the next slide, as we have already solved much of that in that. And shift final result one place left. Okay, let's do it in the next slides. Okay, this one we have already done. 64 plus 32 plus 8, that is 104. This is our question number one. Yes, we did it. We solved it with 104. And next we have shift three places right. This is it. Okay, we have already solved it. So we that right shift means divided by 2 power 3. If 3 shifts, then we are dividing by 2 power 3. 104 divided by 2 power 3, that is 104 divided by 8, that gives us 13. And then we have these values. We have also solved this number, shifted it 4 places right. So uh, okay, we had to shift it 4 places left. I mistakenly did it, shifted it 4 places right. So in shifting it 4 places right, then we lost all the bits, but shifting it 4 places left, we got the number 240. Okay, so you can see the correction here. Okay, next one is this is how we added these numbers. We got the result 80. We got the shifting 3 places right. We got the number as this 1010, and then we got this value. Now we have to add these values, adds part D and C. So adding D and C, we get the value 85. How we add 0 plus 1, that gives us the final result. Now we have to shift this result to the left. What will be it be presenting? It will be representing this number will be representing the. Okay, let's do it here. This number will be representing 170. How? That we are shifting it one place is left. So if we put see from the left side, the left 0 will be vanished. 1 0 is coming 1 0 1 0 1. So these are 3 plus 4 7, and 1 0 will be added as we have shifted all the digits to the left. So now you can say 1 2 4 8 16 32 64 and 128. You add all of them, you will get the result as 170. So this is how you get the result. Okay, we are already done with 2's complement. We have done the addition, we have done the binary shifts here. So this is what our revision has happened. We have done the activity. Let's end our class today.